Okay, we're going to review how to solve logarithmic equations. And I've put a step-by-step process here in order to do that. And the process is that first thing you want to do is to isolate the log function. I put isolate the or isolate a log function because sometimes you have more than one. So you've got to get one by itself. So the equation either looks like this, where you have log equals to a number or an expression, as the case may be, or one log equals another log. Okay, but you have to have one log on a side by itself. Okay, so the first thing you want to do is isolate. Now, if you've written it in this form where you have log equal to an expression, then to solve it from there, you're going to write it in exponential form. If you have logs on both sides and they're the same base, then you can just drop the logs, because the only way the logs will equal is if what's inside is going to equal as well. And then you solve the resulting equation. Now, you always need to make sure that your answers are in the domain of the log function, and you've got to remember that you cannot take the log of a negative number. Now, when you're doing this, you may need to use some of these properties of logarithms to help you isolate the logarithms if there's more than one. And the product rule is like the product rule for exponents. When you're multiplying, you add. But what we would do is if we had two logs being added, we bring it together as the quotient. And the same thing here, if we had two logs being subtracted, we subtract exponents when we divide, so we'd write it as a quotient. And we've already reviewed the change of base formula in a previous video, and then some of the rest of these are inverse properties. And then this is the power rule, where if you have a log of something raised to a power, the power gets multiplied by the individual log. All right, so let's get started and do some log equations. The first one is to solve log base x of 125 equals 3. Now, in this case, I've already got the log isolated. All of this is part of the, all of that is part of the log. So it is on the left side by itself. So what I'm going to do is I'm going to change it to exponential form. And keeping in consistency with some of my previous videos, I'm going to color code these. So the base of the log is x. Well, I said I was going to color code it, didn't change the color. Base of the log is x. So I have x is the base of the exponent. What the log equals is always the exponent, so that's x to the third, and that's going to equal 125. Now, once you get here, you're done with logs. You have no more logs to worry about. So that's x cubed is 125. This is a cubic equation, so we're going to take the cube root of both sides. So we'll do the cube root of x to the third and the cube root of 125. So x is going to equal 5. Okay, but the key there is changing from log form to exponential form. All right, let's take a look at another example. Log base 4x equals 2. All right, so this one, we have the log on the left side by itself. So we are now going to change from log form to exponential form. So the base of the log is 4. So the base of my exponent will be 4. What the log equals is always the exponent, so that's 4 to the exponent of 2. And that equals the third value in that equation, which is x. Now in this case, x is already by itself, so all I have to do is evaluate 4 squared, which we know is 16. But if that was something like 4 to the 2.1, you can certainly use your calculator to solve that. Okay. Now 16, just a reminder of the check. Here, when I check 16 here, it does not make the log, what I'm taking the log of negative, so I know it's going to work. Okay. Now this one has logs on both sides, if you notice. And just a little reminder that when you have ln, that's log base e. And it doesn't really matter in this case as long as the base is the same. That could be log base 3 on both sides. But the point is, the only way these two logs can equal is if the inside equals. So we can pretty much just drop the log, and that would leave us x plus 2 equals 5x minus 8. And you can only do that when you have logs on both sides, one log on each side, and they have the same base. And now we're totally done with logs. This is a linear equation. So all I have to do is I'm going to move the x to the right side, and then I'll move the 8 to the other side. So I'll have 10 equals 4x. And then when I divide by 4, 10/4, that's going to be 5/2, and that's going to equal x. Now, one thing you should note, however, if I were to take this 5/2 and plug it in here, 5/2 plus 2, that's positive. 5/2 times 5, that's 25/2, that's 12.5, minus 8, that's going to be positive as well. So it works in both of them. So it satisfies the domain. Okay, now, this problem does not have logs on both sides, and even if I were to move this log over here, I've got this extra 1 here, okay? So I can't do this by trying to get the logs on both sides, but what I do have to do is I have to isolate the log. I have to get one log on one side by itself. Now, the thing is, these two here, when we combine these, we're going to combine these using the property. We're going to use the property, and we're going to use the product property. Now, why are we using the product property? We're using the product property because it's addition. Now, let me go back to that screen so we can see it. The product property, as you can see, is two logs being added means I can write them as one single log of the product. So we're going to take that and we're going to write that as one single log, log base 3 of x minus 2 times the x. So we took this x minus 2 and we multiplied it by the x according to that property. Now, this problem is very similar to one of the problems from your test. It was very similar to number 7 from the test, and that's going to equal 1. Okay? Now, once we get there, I'm going to go ahead and multiply. That's log base 3 of x squared minus 2x. Okay, so now I have a log by itself on the left. Now let me backtrack to the very first screen. That log is in this form, okay? Because I don't have logs on both sides. If you have logs on both sides, you can simply drop them. But this one is in regular log form, so I'm going to change it to exponential form. So now we're going to change it to exponential form, and I'm going to color code as I go. The base of the log is the base of my exponent, 3. The exponent is what the log equals, 3 to the first power equals, and then my other expression is the x squared minus 2x. Okay? So now once I get there, I'm done with logarithms totally. So that's 3 equals x squared minus 2x. This turns out to be a quadratic equation. So I'm going to set it equal to 0 by moving the 3 over. And it does factor. And I get x minus 3 and x plus 1. And we know when we set each one of those equal to 0, then the opposite sign will be our solution. So we'll have x is positive 3 as a solution, and x is negative 1 as a solution. But I'm going to show this to you. If you were to take the 3 and check it in our logs, 3 minus 2 makes a positive, so that's okay, and 3 is positive here, so that's okay. But if I check negative 1, negative 1 minus 2 is a negative. You cannot take the log of a negative number, so we have to rule that one out as our solution. So the only solution is x equals 3. All right, let's take a look at another one. This problem is similar to number 8 from your test. Now in this case we have logs on both sides, but on the left side we have 2 logs. So we can't drop the logs yet, the definition, if you go back to my original screen, it has to be 1 log on the left and 1 log on the right before you can drop the logs. So the first thing we're going to do is we're going to use the quotient property, because on the left we have subtraction. So subtraction means to divide. So I can combine these two using the quotient property. So I can make them into 1 log of the quotient. So that would be log of x plus 10, the first log, divided by the expression in the second log, x plus 4, equals log of x. Okay. Now, I just wanted to remind you, since we're here, both of these are log base 10. It's understood to be 10 when it's written LOG. But since I have logs on both sides, I can drop them, because the only way these two expressions will equal with the logs is if what I'm taking the log of is equal. So now I have x plus 10 over x plus 4. And that's going to equal x. And then now we're totally done with logs. We're going to solve this rational equation. So I'll do that by multiplying both sides by x plus 4. Let's get it out of the denominator on the left. So it cancels out on the left. And so now we have x plus 10 equals x squared plus 4x, which is quadratic. So I'll set it equal to 0. When I move the x and the 10 over, I'll have x squared. Because I subtract the x, I'll have 3x. And then I'm going to subtract the 10, so it'll be negative 10. And that does factor, the factors of 10 that make 3 are going to be positive 5 and negative 2. So then we know from our previous test that that's going to leave negative 5 as our solution, or positive 2. But once again, we have to check. So let's take the first one. I have negative 5. Negative 5 plus 10 is okay, because negative 5 plus 10 is a positive. But negative 5 plus 4 is not okay, because that's a negative. So we can rule out the negative 5. And let's just double check the 2. We're going to check the 2. 2 plus 10 is a positive, 2 plus 4 is a positive, and 2 itself is positive. So the only solution there would be 2. Okay, let's wrap that up.